I almost forgot to tell you about this important limit as x goes to infinity of sine x over x. So this might look familiar, and don't get this confused with what we had done in the past. The limit as x was approaching 0 of sine x all over x. This was equal to 1. And we showed that using the sandwich theorem, or the squeeze theorem is another way to call it. If we were looking at this, though, the sine of x as x goes to infinity of sine x over x, let's kind of think about this. And so notice that this is two separate functions. We can think of this as, and just using rules of limits, this is limit as x goes to infinity of 1 over x all times sine of x. And so if we had 1 over x, we know is continuous and it has a limit. And sine of x, we said didn't have a limit yesterday. Remember, it was as x goes to infinity, it was bouncing back and forth between -1 and 1. The thing is, though, if we take something bouncing back between -1 and 1, and we're multiplying it by something that's going to 0, this piece goes to 0. 0 times anything is 0. And so if we're looking at the limit of the sine x over x, this is equal to 0. And so that's an important limit to know. And the same thing happens as the limit as x goes to negative infinity of sine x over x. Oops, I forgot to put the negative. That also is equal to 0. So for instance, if you had the limit as x was approaching infinity of sine of 2x all over x. So remember when we were using the limit as it went to 0, these arguments in here, the sign of what we were taking had to be what we were dividing by. And we were able to manipulate that by multiplying again by fancy ones. And so notice I want a 2x in the denominator here. And so actually, I don't think it really matters, but I can show it this way. This right here, right? I can rewrite it this as the limit as x goes to infinity of sine of 2x all over 2x. And then I still have this 2 from the numerator. But this is a constant. Remember, if I have a limit of a constant times some function, I can take that constant times the limit of the function. So again, just kind of applying my rules. I'm not always writing these down. Of limits, and have 2 times the limit as x goes to infinity of sine of 2x over 2x. So this is 2 times 0, which is 0. So just watch for that. If you see something like that, where you can manipulate it, where you have sine of something over x, you can manipulate it to be the same, then you can use this fact that it goes to 0.